Howdy, folks. How we all doing today? All right, we got one more section to cover here in polynomials. So we're going to get to a real big theorem. It's called the Fundamental Theorem of Algebra. We've only got a handful of fundamental theorems in math. The next one we don't get till calculus. So this is a pretty big one, and these big ones, honestly, they're really kind of hard to prove. And basically what it says is no matter what the degree is, as long as the degree is greater than 1, the degree is always going to be the maximum number of roots. In other words, say I have a function like f of x equals x cubed minus 5x squared plus 7x minus 3. Whatever the degree is, in this case the degree is 3, this means that I am going to have either 3 real roots or, like we were talking about last class, you could have complex roots with those. And now complex roots are like radicals. They always come in conjugates. They always come in pairs. So if I could also have a complex root, but if I have 1, that means I have 2. So I could, if I have 2 complex roots, that means I still need to have 1 real root. But no matter how many roots there are, they will always be equal. The number of complex roots or imaginary roots, altogether the real roots and the imaginary roots will always be equal to the degree of the polynomial. So we're going to essentially just go one step further. We're not going to go too far. We've covered a lot of ground here so far. We're just going to continue looking at solving our equations, but just realize solving our polynomials, but just realize sometimes the answers are going to have imaginary numbers. Not all going to be real. So we get a problem here. Let's start off with this first one. They're telling me what one of my roots are. And because I see the degree of 3 here, that means I know I have 3 complex roots. Could be 3 real roots, or it could be 1 real root and 2 complex roots. Well, friends, if I know that I have this root, x equals 1/2, 1 minus I root 5, then I know that that is an imaginary root. So knowing that, I know that I'm only going to have 1 real root then and 2 imaginary roots. So I know that this right here, x equals 1/2, 1 minus I root 5 also is a root. So that's our first root. But just like radicals, again, these also have to come in conjugates. So if 1 minus I root 5, if that was giving me a root, that means 1 plus I root 5 also has to be a root, because again, they come in conjugates. Just like our radicals come in conjugates, our imaginary roots also come in conjugates. So if I have these 2 roots, x equals 1/2, 1 minus I root 5, and x equals 1 plus I root 5, my job is to find the other one. So I could P over Q it if I wanted to, not going to. I know that if I have 2, there's probably a better way I can do this. So do me a huge favor. Go ahead and pause the video and turn both of these roots into factors. All right, well, let's see how you did. First of all, I see a 1/2 here. I don't like having a 1/2 here. So if I multiply it by 2, that's going to get rid of the 1/2, moves it to the other side. 2x equals 1 minus I root 5. and we move it all over to the same side. Remember, we always keep x positive, so 2x minus 1 plus I root 5 equals 0. So I got one factor there. And same thing, get rid of that 1/2 if I multiply it by 2. We have 2x equals 1 plus I root 5. And then to turn into a factor, set it equal to 0. So 2x minus 1 minus I root 5. Friends, all right, now we got two factors. I am looking for the third factor. So I'm going to go back and do my polynomial long division like we did, oh, what was that, a couple days ago? 2 days ago, 3 days ago? I'm going to use my generic rectangle, I think, to help me out here. So first thing I'm going to do is I'm going to take my two roots that I know, and I'm going to multiply them together here. So I had 2x minus 1 plus I root 5. 2x minus 1 minus I root 5. So when I multiply these first two roots together, let's see what I get here. I got 4x squared minus 2x minus 2x positive 1. And this would be minus I squared times root 5 squared, so that's just 5. So I have minus I squared, which was a negative 1. So negative times a negative 1 times 5, which would be equal to a positive 5. Now, the reason why I haven't touched the other ones yet, we already saw that when we were dealing with radicals, that these kind of went away. So turns out with imaginaries, because they're conjugates, same thing is going to be true. They're going to multiply out to go away. So plus 2I root x root 5, that's a lot of stuff right there, minus 2ix root 5. Notice those two terms cancel each other out. Likewise, minus I root 5 and positive I root 5. And again, anything that has an imaginary number, just like anything that has a square root, a radical, always go away, and I'm left with 4x squared. So when I multiply these two roots together, I get 4x squared minus 4x plus 6. Well, friends, that means in order for me to figure out my last root, I'm going to divide 4x squared minus 4x plus 6 into that. So in other words, to find out my third root, I'm going to take 8x cubed minus 14x squared what is that? 14x squared plus 18x minus 9. And we're going to divide that by our 4x squared minus 4x plus 6. So again, this is where we're going to do our polynomial long division to see what factor is left, because whatever factor is left, that's what I'm going to be setting equal to 0 to find my third and final root. I know complex roots. My degree is 3. I had to have 3. 2 of them were imaginary, so I know that I have to have some sort of real root here. All right, so that first term, that's got to go in the top right. And my last term, the minus 9, that has to go in the bottom left. And like we saw before, this diagonal is going to be equal to negative 14x squared. And this diagonal is going to be equal to a positive 18x. Now, we're not going to spend too much time practicing these. Once we finish this one, we're going to move on to do the two things that we really need to do the most work with. So that way we're good. Plus 6. All right, and now we're going to go through and see if we can't figure all this stuff out. Well, it looks like I have a 2x here. And if that's 2x, that means this right here needed to be, 2x times negative 4x would be a negative 8x. So if that's negative 8x and I need a negative 14, that means this needed to be a negative 6x. And that should be squared, not x, by the way. So we're going to 4x squared times negative 6x squared, that'd be a negative 3/2. Well, that's ugly. That's all right, though. And we're going to keep going in here to see if our numbers match up. They need to match up here. So 2x times 6, that'd be a positive 12x. So the positive 12 from this and this empty box need to add up to positive 18. So let's make that a positive 6. And let's see here, negative 3/2 times positive 6, that would be, is that negative 4? Is that negative 4 there? Let's see here, we divide by 2. Oh, it doesn't look like it, does it? Interesting. So maybe it doesn't work, huh? Maybe it doesn't work. Maybe it does. Nah, it works. I'm just playing it. All right, so positive 6 there. So 3/2 times 6. All right. So that would end up giving us, or 3/2 times 4 would give us positive 6. That works. All right, next up, we have a positive 6, negative 3/2. More fractional fun. Careful, does it work? Yeah, again, it works. All right, so just giving you guys a hard time here. We want to make sure that we have our fractions down really well. So it turns out this 2x minus 3/2 looks like it could be another factor for us. Again, I don't like the way that factor is written, but that's fine. We're not really writing things as factors. What we're trying to do is we're trying to solve them. 2x, all we care about is the roots. So that equals 3/2. And then to get rid of the 2, I'm going to multiply by 1/2, which is the same thing as dividing by 2. But since I have a fraction on this side, I think multiplying by 1/2 makes it a little easier. And friends, I find out that x equals 3/4. So if I'm given two imaginary roots, or one imaginary root, I could combine it with its conjugate to figure out what the other real root would have to be. And again, the number of roots I have to be equal to the degree. The number of complex roots will be equal to the number of the degree. So let's keep going here. The things that we're really going to have to do the most with. Yep. These are the things we're going to have to do the most with. What I'd like for you guys to do is I'd like for you to find a polynomial. And count this as problem 1.5 on your notes there. Find all the zeros of this polynomial. And we're just going to do it as our P over Q thing again. So don't think we're going too crazy. So I want you guys to write this one in here just for the fun of it. F of x. I meant to make that black. F of x equals 3x cubed. If we can factor this, well, you would try to factor this, but friends, this one does not factor. So sad. Minus 4x plus 4. All right, so what I want you guys to do is your P over Q's, use your rational root theorem, see if you can figure out what all the roots are. All right, go ahead and pause the video and get started. Go for it. All right, let's see how you did. So I know my 3 is here. My degree is 3. I'm going to have at most 3 complex roots. 4 is my last number, therefore that's going to be my p-value. So I'm going to list all my factors of p plus or minus 1, plus or minus 2, and plus or minus 4. So this hasn't changed. Now I'm going to find all my factors of my q value, so my leading coefficient. There's my q. All right, so what's q then? Q is plus or minus 1, and we have plus or minus 3. That means all my roots will be in the form of p over q. That's irrational. This does not count the complex roots. It's just irrational ones. They would have to be in the form of all the p's divided by all the q's. So we're cutting it from infinity down to 12 options. Now, again, some of you guys are still thinking that's a lot of work. Plug in your graphing calculator so you choose correctly. If it's on the non-graphing calculator portion, well, you will just be adding up. Or you're just going to try them at random until you find one that works. It happens. No harm, no foul. So here we go. We're going to have to figure out, try one of our numbers that works. I'm going to put all my complex numbers in here. Oh, I'm sorry, not complex, my coefficients in here. So I have 3, I have -5, I have -4, and I have a +4. So let's see here. If I want to try a number, I know 1's not going to work because the coefficients don't add up to 0. Let's try a -1. Maybe that works. All right, I need a placeholder. Always put a 0 here. And remember, we add going down, and we multiply by the box going up. So I'm going to add going down. In this case, it was 3. And I'm going to multiply by the box going up. So I'm going to multiply by -1 going up. So 3 times -1 is -3. Add them up, -8. -1 times -8 is a +8. That's 4. Oh, turns out we got lucky, friends. And if the remainder is 0, that means that I have a factor. So this worked, right? We got a little lucky there on the first one. So 3, was it a cubic? This brings me down to a quadratic. So if I'm looking for my zeros, friends, I got one. And the nice thing is if I found one, I am not doing any more real numbers because there's no guarantee that I'm going to have another rational root or real number. I have to go through and I'm going to try to either factor it or do the quadratic formula. No sense messing with it. I have my one that worked. And I'm going to go and try to figure out the other two. So for me, I'm going to use quadratic formula. I don't know what you use. I'm kind of curious. So -b plus or minus, x equals a -b plus or minus the square root of b squared minus 4ac all over 2a. I'm telling you, it just rolls. All right, let's see here. I may have gotten lucky. It might factor. Could have probably factored this one. By the way, I could have factored this one. So 4 times 3 is 12 times 4 is 48. So 64 minus 48, well, that's going to be 16. Turned out this one worked. Could have factored this one. That's kind of cool. This one actually ended up with 3 real numbers. So we're going to go through and figure these out here. So 8 plus 4 divided by 2. And then we have 8 minus 4 divided by 2. I usually, if I can spot it real quickly that it's going to be something that I can factor, I'll do that real quick. If not, I'll just quadratic formula. If it works, great. If it doesn't, no harm, no foul. No harm, no foul. Oh, I did forget to do some. That was kind of goofy of me. Let's just fix it real quick. This was 2 times 3, so that should have been 6 down there. So 2a would be 6, 6. And again, I know you guys are screaming at the screen, William, stop it. I know. Sometimes I can't get out of my own way. 6 there, and that would be 2/3. So we ended up with 3 roots, just like the degree said we were going to have. Just so happened that these zeros, these roots, they were all real numbers. They were all fractions. And again, we've already kind of looked at this a little bit. So let's have you guys try another one here, if you don't mind. And if you do mind, well, deal with it. We can't get enough practice at this. Why don't you guys try? Oh, try that one. All right, so we did problem 1.5. How about problem 2? All right, go ahead and pause the video, P over Q it, see what you come up with, and we will go for it. All right, good luck. All right, well, let's see what you guys came up with here. I noticed that I have a 4 here. Wow, means I'm going to have at most 4 roots. Well, I will have 4 roots. They could be 4 complex roots. They could be 2 real and 2 complex, or they could be all 4 real. Won't know yet until we actually go through and figure it all out here. Let's see here. My p-values. Well, that's not too bad. So p is plus or minus 1, plus or minus 3. Let's go figure out our q values here. Did a circle for the last one. We'll try a rectangle for this one. All right. Well, 2, again, that's not too bad. So plus or minus 1, plus or minus 2. Can already see that all my coefficients are positive numbers, so 1 is not going to work. That's not going to make it equal to 0. But even still, it doesn't matter. We'll still see if we can't figure out some things. All my p's, all my q's. You got to realize this was letting me know if there's any rational roots. Right? All these numbers could have been irrational, in which case some of them we just can't necessarily do without using some sort of graphing calculator, some sort of software. But we're trying to see, are there any of these that might potentially be numbers that would work out for us? Any of these that might be rational numbers? So I'm at a quartic. I'm going to put all my coefficients in here, 2, 7, 5, 7, 3. All right, so I got to try one of these 8. If you know something about upper bounds, I know that the answer is going to have to be a negative number. If you don't know anything about upper bounds, don't worry about it. It's not the most important thing in the world. I mean, it helps a little bit when we're guessing and checking, but it's more of a kind of a useful thing back in the day, back when I was a kid. And we did not have graphing calculators in class. Sadly, not sadly, good thing. We do have them now, makes life a little bit easier. Notice, turned out -3 actually is a pretty good choice, because my factor was 0. So I went from a 4th down to a cubic. X plus. All right, so we're going to have to solve that one now, right? So I have 2, I have 1, I have 2, I have 1. By the way, let's take a quick little gander here. Notice my p-value changed, right? I no longer have 3 as my p-value. My p-value is now +1. So anything that had a 3 in it before, I could actually cross off, because my p-value doesn't have any 3's in it. Well, this makes it pretty easy. I know it's not 1. So it's either going to be -1 or it might be one of these fractions. I'm going to try that -1/2. I'm feeling pretty good about that one. Let's try that one. I got -1/2. So I need my placeholder again. Curious to see, did you guys try the fractions? Well, you would have had to have. If you solved it all the way down, you would have had to have. And again, notice my remainder is 0, so I have one that works. So far we found out that x equals -3. We have x equals -1/2. And now for the fun and enjoyment of it, friends, we are down to 2x squared plus 0x plus 2. And we got to solve this one to see if we can't figure it out. So I'm not going to bother even factoring this one. I only have an x squared. I'm going to divide by -2, subtract 2 from both sides, divide by +2. And then from there, friend, I'm going to go ahead and take my square root. Don't put the plus or minus in between it. X equals a plus or minus. Again, the square root of -1 is I. Well, here's my last two. X equals a plus or minus I. The number of roots equals the number of complex roots equals whatever the degree was. That's the fundamental theorem of algebra. Let's go on and take a look at our last thing here. Using the complex zeros, see if we can't find a polynomial. Oh, so we did this again already as well. We did this with the with radicals. So now we're just doing it with imaginaries. So x equals 4. I know that's a root. And I see that x equals 2 minus I is a root. Now that's going to tell me something here. I got to be careful now. By the way, when we get to this problem down here, I'm going to have you guys put an I in front of that. X equals 2 minus I. So if those are my two roots, student math students you are, what else has to be a root? Yeah, you got it. It's the conjugate, so 2 plus I. So we're going to take them from roots. We're going to set them all equal to 0 to turn them into factors. So x minus 4 equals 0. X minus 2 plus I equals 0. X minus 2 minus I equals 0. And then everybody's personal favorite thing, it's a little tedious, but is what it is. We're going to multiply the whole thing together. Now, friends, which two would you multiply together first, you think? Doesn't matter, honestly. But for me personally, I would definitely multiply the two imaginary numbers together. So let's go ahead and start with that. So I'll get to the x minus 4 here in a second. Let's multiply our two imaginary numbers together. All right, we have a factor with 3 terms, another factor with 3 terms. And we are going to multiply those imaginaries together. So x minus 2 minus, plus I, x minus 2, and again, here comes conjugate, minus I. You can multiply it all the way out. We have x squared minus 2x minus 2x plus 4 minus I squared. So minus a -1, which is a +1. So I ended up with x squared minus 4x plus 5. But again, I'm going to go back and multiply out the rest of that box here in a second. Just so I want you to see again that if we do this right, the imaginary terms will always go away. So what do we have here? A positive ix and a minus ix. Notice how the i's go away, right? No harm, no foul there. What about here? We have a minus 2. And we have a positive 2i. Notice again, any term that has an I will go away. So we're going to multiply then our last little bit. These last two terms together so we can actually figure out what the product is. So x minus 4, x squared minus 4x plus 5. Oh, that's a weird looking 5, isn't it? All right. And again, multiplying all the way out, I get x cubed minus 4x squared plus 5x minus 4x squared It's an ugly 2. I don't know, man. I'm telling you, I struggle writing 2s. With this mouse, struggle writing 2s. Oh, positive 16x and a minus 20. So when I combine those like terms, I would have my polynomial. Here we go. F of x equals x cubed minus 8x squared. Oh, what's that going to be? 5 and 16, that's a positive 21x. And a minus 20. All right, friends. Why don't you pause the video here and try the next one. Set and go for it. All right, let's see how you did, huh? So we got a 4. We got a 3 minus I root 2. So we know that those are roots. And you know that we take a conjugate with a imaginary number, we take a conjugate with a complex or a radical. Well, in this case, it's both. So we would do a combination or a conjugate if it's both as well. So x minus 4 equals 0. Turn each of these into factors. I know you guys already did that. At least I'm going to pretend you did, and I tell you what. X minus 3 plus I root 2. And we have x minus 3 minus I root 2. And we are going to multiply them all together. Which you guys already did that. I am just playing catch up. So let's multiply those imaginaries together. Let's see how that looks. Put some lines in here. So I got an x minus 3 plus I root 2. x minus 3 minus I root 2. And we're going to go through and do some multiplication. X squared minus 3x minus 3x plus 9 minus I squared times 2. So that would be a negative times negative 1 times 2. And if I multiply all that together, I get a positive 2. A little bit of multiplying, a little bit of me, and a whole lot of you. There we go, friends. We are just multiplying like there is no tomorrow here. And that would be a positive 11 there. And again, just to make sure that we did this correctly, I'm going to go ahead and multiply this all the way out. I x root 2. I want you guys to make sure, I want you to be firm in your mind that these are going to go away. If we did this right by the conjugates, and don't take the shortcuts, you guys actually should be multiplying it out. Double check, because if you, this is a great way to check as well. If you did the conjugate wrong, all your terms, all your imaginary terms in your radical terms won't go away, which we obviously want them to do. Like these right here, they go away. So lastly, we're going to have one more box together, like so. And we're going to do some multiplying. So I have x minus 4, x squared minus 6x plus 11, and when I multiply it, friends, all the way out, I have x cubed minus 6x squared plus 11x minus 4x squared plus 24x minus 44. And friends, I believe that we have done some multiplying here because, ooh, multiplying is fun. Hey, I like it. All right, so that takes care of all of our polynomial stuff. And again, I know some of you guys, we had to go a little bit longer on a couple of videos just because back in the spring, the COVID stuff, you guys missed some of this. But at this point in time, we would have covered everything that you would have needed to cover for all of the polynomial stuff. So you guys are hopefully on your heading into your Labor Day weekend. All right, so enjoy your 3 days off. But we will come back tomorrow, the next class, and we will be taking a look at a little bit more of this and getting ourselves all cleaned up, ready to go. So as far as polynomials go, so if there's anything we got to freshen up as far as really just hammer home and make sure we have it all, we'll be doing that then. So study up, and I'll see you guys the next morning, next class.